Hello, Matthews, Gatos here. In this lesson, I'm going to go over the practice test. So you'll just see me doing all the questions, so you can fast forward to whatever section that you need, pause, rewind, etc. By no means do you have to watch the whole thing. So let's start with question number 1. Which of the following is not possible for the graph of a polynomial function of degree 3? So degree 3 is those cubic ones, so it could maybe look like that, or just the slides, kind of like that. So is it possible to have no turning point? Yes, it is, because you could have an inflection point. Is it possible to have one turning point? No, you have to have one turning point to come up and then another turning point to turn the other direction, because the arms have to go in opposite direction. If I only had one turning point, I would have a quadratic like that or like that. So this would be your answer here. The end behavior of the graph of a polynomial function is such that the left tail is down in quadrant 3 and the right tail is down in quadrant 4. The degree of this polynomial could be which? So we have a left tail down in quadrant 3 and a right tail down in quadrant 4. Basically what this is telling you is that the ends of the graph go in the same direction. So I know that it's not going to be degree 1 or 3 because linear and cubic function have end behavior in opposite directions. If it was degree 0, it would be a constant function, which is a horizontal line like this. So it has to be option 2, which would be a quadratic degree 2. Okay, the graphs of 4 cubic polynomial functions are shown. Write the graph corresponding to each of these. Okay, so what I look at here is I notice that all of them have a different constant value. They all have different y-intercepts, but my graph isn't labeled with a scale. So that will help me narrow it down. So I'm going to use my y-intercepts combined with my leading coefficient. So I have, let's look at our positive y-intercepts. So there are the graphs that have a positive y-intercept are this graph here and this graph here. So to know which one is which, I'm going to look at my end behavior. So see in this one here, left arm is down, right arm is up, kind of like a line that slopes positive. So this one here has a positive slope, which would be this graph right here, this equation right here. So graph number 1 corresponds to this second equation. So I'll put a 1 there. This graph here with a positive y-intercept has end behavior left tail up, right tail down, kind of like a negative sloping line. So that makes sense for this one here, which is a negative sloping line. So graph number 4 would go with the first equation. So I'll put a 4 there, a 4 and then a 1. Okay, now these ones here are the ones that have the negative y-intercepts. So both of these have negative y-intercepts. And again, let's look at the end behavior. So left tail down, right tail up, that's like a positive sloping line. So that would be this one here. So the last graph is represented, or last equation is represented by graph 2, which means that this equation must be matched by graph number 3. So the answer to that one would be 4, 1, 3, 2. Okay, the graph of a cubic function has, okay, we're talking about x-intercepts and y-intercepts. Okay, so first of all, I see that I have 2 different factors, so I'm going to have 2 different roots, so not 3. I bet you the reason there's have 3 as an option is because this is squared, but that would not give us 3 different intercepts. It would just give us 2 with one of them repeated. So it's definitely A or C. So to know if my y-intercept is positive or negative, I'm going to let x equal to 0 and find y. So I've got y equals negative, 0 take away 3, 0 plus 1 squared. So this will be negative. Well, let's do it this way here. A negative, negative 3 is a positive 3. 2 negatives make a positive, and 1 squared is 1. So 3 times 1 is 3. So it is a positive y-intercept. So C would be your correct option. Okay, number 4. Which of the following 2 rows includes 2 functions that have similar end behavior? Okay, so the ones that are the same, quadratic is never the same as cubic. So definitely not that as an option. And then let's see what else I can knock off. So x squared. This one here has a positive leading coefficient, so it's opening up. This one has a negative leading coefficient, so it's opening down, so that one doesn't make sense. This is a line with a positive slope, so it'll kind of look like that. This is a line with a negative slope, so it'll look like that, so that doesn't have the same end behavior. Let's hope this is right. Positive leading coefficient, good, and positive leading coefficient. So I don't know what it's going to look like in the middle, maybe like that, or maybe like, oops, let me draw that again, or maybe something like that without putting it into the calculator. But I do know positive leading coefficient, the ends are in opposite direction like a positive sloping line, so D will be my option. Okay, the polynomial function shown in the diagram can be written in this form. Okay, let's see what we got going on here. So I have an x-intercept right here at -2, so my factor will be x plus 2. So I can knock off this as an option. And let's see the next one here. So this has an x-intercept at 4. So the factor is going to be x minus 4. So I can knock off the plus 4 as an option. Now, really what we have to decide is one of them is squared and one of them is not. So the factor that has a square on it is going to behave like a quadratic. So if it was a line, it would just be passing through like that. If that was just the only x-intercept, it'd be passing through. If I have 4 here, see how it touches and turns around, it doesn't cross the x-axis? That's like a quadratic, and a quadratic has a degree of 2. So I know since a quadratic has a degree of 2, this factor here will be squared. So it won't be this one here. It has to be the option, it's not, that one's not going to be squared. It has to be the option of C. Okay, so you can even put that into your calculator just to check. You can choose any a value, because if it's true for all a values, it will be true for the a value that you select. Okay, let's look at B. So Roger, Andy, and Serena investigating graphs of polynomial functions. After graphing some functions on his calculator, Roger made 4 conjectures about the graph of polynomial functions. So graph of a polynomial function of degree 0 has 0 x-intercepts. The graph of a polynomial of degree 1 has 1 x-intercept, degree 2 has 2, and the graph of degree 3 has 3. Andy was asked to draw the graphs that satisfied the conditions of the conjectures. All of the conjectures for which this can be done. Okay, I can draw a degree 0 with no x-intercepts. Let's put in like a little x-axis here for all of these. Now it's not always true, but I can draw it so that it would be true for all of these actually, and I just want to show you how. Okay, so we'll make this into like a little XY coordinate grid, okay, like that. Group it, and then we're going to just look at each of the conditions. So condition number 1 was that we have a degree 0 with no x-intercepts. So I could have something like that, like this. So that can be done. Okay, let's look at conjecture number 2. So conjecture number 2 is that I have degree 1 with 1 x-intercept. So there's a degree 1, 1 x-intercept. And then polynomial degree 2, 2 x-intercepts. So I can draw that like this, and there's 2 x-intercepts. And a polynomial function degree 3 with 3 x-intercepts, so I can go like this. And you can see I have 3 x-intercepts. So all of them can be drawn so that it satisfies all the conditions. Serena was asked to draw graphs that provided counterexamples to the conjectures. So in other words, try to come up with an example where this can't be done. Okay, so let's look at this. So can we draw a polynomial degree 0 that has no x-intercept? Something that, in other words, does have an x-intercept. And yes, I can, because this graph here is a constant function, but it has infinite x-intercepts. So I can draw a counterexample for that. Degree 1 will always have 1 x-intercept, so I cannot draw a counterexample for that. Okay, degree 2 with 2 x-intercepts. Yes, I can draw a degree 2 with no x-intercepts. And then polynomial degree 3 with 3 x-intercepts. Yes, I can draw a counterexample for that. Something that looks like this. So I can do that for everything except for number 2. So 1, 3, and 4. Okay, Which of the following graphs could be the graph of a polynomial of this function here? Okay, let's just look here. So we have x, now a is less than 0, so I'm going to have, I'm going to be subtracting a number, so it's going to be x minus a squared, since a is less than 0. B is greater than 0, so it'll just be x plus b. And then c is less than 0, which means it's a negative leading coefficient. So let's start with negative leading coefficient first. Negative leading coefficient is like a negative sloping line, since it is a cubic polynomial. So I can cross off b as an option, and I can cross off c as an option because the arms are going in the same direction. So I've got it down to a or d. So looking at the one that is passing through, if my factor is x plus b, that means that my x-intercept will be x equal to negative b. So I'm looking for a passing through negative. Passing through negative. This is not a passing through negative, so I know it's not that. It has to be this one here. So A would be the answer. Okay, a projectile is launched into the air. The height of the projectile above the ground is modeled by this quadratic equation, where h represents the height and t is the time in seconds. To determine the height of the launch site above the ground, what characteristic of the graph could be analyzed? So if I want to know where it is launched, that's kind of like the initial value, which would be the y-intercept. But in this case here, they don't have y-intercepts, they have h-intercepts. So it would be the h-intercept. Okay, the maximum height above the ground reached by the projectile to the nearest tenth of a meter is what? So we want to put this into our calculator and find the vertex, because we want to have the maximum height. What do we want? The maximum height, yes. Okay, so let's go into our calculator and enter this equation into our calculator. Okay, so I've got negative 4.9 x squared plus 41x plus 8.2. Okay, so let's adjust our windows. Now h is the height of the projectile in meters, and x is the time. So, I don't know, let's say it's in the air for 10 seconds. I can always adjust this after. Go up by 1. And then the height will go from 0 to, let's say the height is 100 meters. And we'll go up by 10. So I'm just guessing for my window setting. I can adjust anything after. Okay, so I'll hit graph. And that's actually not a bad window setting. Okay, and I want to find the maximum height, which is this vertex. So into my calculate menu, second trace, I'm going to choose option number 4, which is maximum. And I'll go just to the left and press enter. And then go just to the right and press enter. And enter again. And I will get this as my maximum. So let me just copy this over into our notes so that we can see which one is the answer. And paste it. Okay, so for this one here, I am looking for the maximum height. And I can see the maximum height is actually the y-coordinate of the vertex. And I will do that to the nearest tenth, which would be 94.0. 94.0, yes. Okay. Okay, for the next one here, we have a metal rod that is heated. The length of the rod measured at various temperatures. Due to an experimental error, the data does not support perfect linear relationship. Write a linear regression. A linear regression is performed on the data. The slope of the linear regression is what? Okay, so we're going to put this into list 1, list 2, and do a linear regression. So let me just clear out my y equals, and I'll turn my plots on. And then I'll go into stat, edit, and I've already entered mine into list 1 and 2. That's what you would do if you haven't done that already. So once you've entered the amounts into your list, I go out, and I'm going to go stat. I will go over to calculate, and I will choose linear regression, which If I go down right here, option number 4, I press enter and I go down and I want to store my regression in Y1. So alpha trace Y1, or if you have a TI-83, you would go vars, yvars, function, and then you'd press enter for Y1, like that, okay? And then we'll go down here to calculate. And it's looking for the slope, which is the number in front of x, which is 0.36. So let's record that over here, 0.36. Now it says, using the linear regression, the expected length of the metal rod at a temperature of 84 degrees Celsius would be what? Okay, so this is an example. 84 degrees Celsius is an x value. So this is an example of x given, y needed. So I'm going to, I could do trace, but then I'd have to mess around with a window setting. So what I'm going to do is I'm actually going to look in my table. And I'm going to find out when x is 84, what is my y value. So if I go into, because I've already copy pasted my equation here into y equals, so I'm going to go into my table, second window, table set, and I'm going to start it at the x value that I want, which is 84. This eliminates me having to deal with my windows. And then I'm going to go into my table, and I can see the y value that goes with that, 124.08. So back over here, and I'm going to enter it in as 124.08, so that's going to be 124 millimeters. B would be your option. Okay, so for this one here, table for the following values taken from a graph of a third-degree polynomial function, the cubic regression can be determined in this form. What is the value of c, the number in front of x? So into our calculators, you want to make sure y1 and everything is cleared, plot 1 is highlighted, and then go out to your screen and go into stat, edit, and then you can enter in the values as I have done for list 1 and list 2. So once you've done that, let's go out into our main screen, second mode, quick. And then I'm going to go stat, calculate, and I want to do a cubic regression, which is option number 6. So go down there, and then I can store it in alpha trace y1 and calculate it. And they're just interested in the c value, which is 12. So back over here, I know that my c value is 12. Okay, which of the following types of function is a periodic function? Periodic means it repeats over and over, and that is a sinusoidal function. So periodic, again, is repeating over time. Which two functions have a similar end behavior? That is linear and cubic. They have the same type of end behavior because their arms point in opposite directions. Okay, this is a partial graph of a sine function. They want to know the value of b. So the value of b is tied to the period. So we need to find the period. So because I don't know where my midline is, I am just going to start counting maximum to maximum. So the distance between the maximum and the maximum is a horizontal distance, which will be the period. So I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my period is equal to 10. So remember the formula on your formula sheet is period equals 2 pi divided by b, but we want our b value. So I said you could just switch around period and b as long as 2 pi stays on top. So b is equal to 2 pi over the period, which is 10. And then I just put 2 over 10 in lowest terms, which is 1 over 5. So my b value will be pi over 5, which is option number C. Okay, for this one here, we have a partial sinusoidal graph represented on the graphing calculator screen, and they have max and min values are integers. Let's look at the scale. It looks like they're going up by 3s. So this would be a maximum of 3, a minimum of 3, 6, negative 9. Okay, so we're answering this for the next 3 questions. So the first one is, what is the amplitude? Okay, well, I know that amplitude is equal to max minus min divided by 2. So amplitude is equal to max minus min divided by 2. So that will be a value of 12 over 2, which is 6. So my amplitude is 6. The period. Okay, we want to figure out what the period is. Now, each one of the scales is 0.52, because remember, period is a horizontal distance, so it's along the x-axis. So if I look at from here to here is my maximum, so this distance in between here is my period. So let's count how many ticks I go. I go 1, 2, 3, 4, 5, 6 spaces along the x-axis. 6 spaces times each space is 0.52. So multiply 6 by 0.52, you get 3.12. So the period would be closest to C, 3.14. The equation of the midline. Okay, that's your D value, and D value is your average, which is 3 plus negative 9 divided by 2. So that's negative 6 over 2, which is negative 3. Y equals negative 3. Okay, number 17. The height of a student above ground on a circular Ferris wheel shown is given by this equation. H is the height in meters, T is the time in seconds. The diameter of the wheel is 12 meters, and a student starts on the bottom of the Ferris wheel at time equal to 0 at a height of 3 meters above the ground. The value of D in the equation is what? Okay, so imagine I have this Ferris wheel here, and here's the ground, and I'm starting the Ferris wheel at a height of 3. So that means that I'm going to have a minimum value of 3. My Ferris wheel has a diameter of 12, so that means all the way through here, diameter all the way through the center is 12. So if I'm 3 above the ground, and then I go up 12, I am then 15 above the ground. So what I want to do is I want to figure out what my D value is. So I'm going to take my max plus my min, divide by 2. So my minimum value is 3, because I'm starting right here already 3 meters above the ground. My maximum value is 15, and then I will divide that by 2. So 3 plus 15 is 18 over 2, and 18 over 2 is 9. Okay, 2 sine functions are shown below. Graph 1 has this equation, a sine bx plus d. The equation for graph 2 can be obtained from the equation of graph 1 by changing some of the parameters a, b, and d. The parameters that are changed are what? Okay, so let's look to see a, b, and d. That's going to be your amplitude, your midline, and then b is tied to your period. So let's first of all trace through one cycle. So I'm going to have a hill and a valley, right, like that. And then I'll have a hill and a valley like that. So since they line up like that, they have the same period. So since they have the same period, that means they have the same B value. So I'm going to knock off anything with a B value in it. Oh, look at that. We got it right away. Okay. Let's say that we weren't left with just one option. You can tell that the midline is different because this one here, the midline, is, remember, it's that imaginary line that splits the graph into 2 pieces. So there's the midline of graph number 2. You can clearly see that is not the midline of graph number 1 because I have had a shift. I have a vertical shift. So they definitely don't have the same D value. Also, if you look at the A value is the distance between the midline and the max. You can see that that A value is much higher than this little A value here. So it's just A and D that were changed. Okay. In a controlled laboratory experiment, the temperature of a greenhouse is controlled by an electric thermostat. The temperatures vary according to this sine function. Okay, so 28 plus, that's kind of a weird way of seeing it. Let's write it how we're used to seeing it. 4 sine of pi over 3 T, and then let's add the 20 on at the end, 28 on at the end. Okay, C is the temperature in Celsius, T is the time in hours. The variation in temperature follows a repeating cycle, the number of temperature cycles in one day. So really, that's just asking you to figure out what the period is. So period is equal to 2 pi over your B value, which is pi over 3. So 2 pi over 3. Now, first thing I notice is that my pi's cancel because pi divided by pi. And then on our calculator, we can go 2 divided by not 3, because that cancels to be a 1, but 2 divided by 1/3. You can do that on your calculator, or just multiply by the reciprocal, and you get 6. So what that tells me is that my period is 6. So the variation, and now that 6 is in the number of hours past midnight. So how many, if I'm going to repeat every 6 hours, how many cycles am I going to go through in a day? So my period is 6 hours, and in one day there are 24 hours, so I'm going to go through 4 cycles, because 6 times 4 is 24 hours in a day. Okay, number 5, to the nearest degree, the temperature in degrees Celsius at 2:30 p.m. Okay, well, 2:30 p.m. is a full 12 hours plus another 2.5 hours. So if we think about this, altogether, that is going to be 14.5 hours. So this is an x value. This is an example of x given and y needed. So what I'm going to do is put my equation here into y1, and in my table value, I'm going to go into 14.5. So let's do that. So we'll go into our calculator into y1. So let me just turn those off. Okay. So in y1, I'm going to enter in my equation, and I'm going to go back to the unchanged equation, so with the 28 plus, exactly as it looked. So 4 sine of pi over 3 t. So, oops, I'm going to go alpha y equals to get my fraction template. Then I'm going to do pi over 3, and then that will be x, and then close my bracket. Now I can see I'm in radians here, but just make sure you go and look at your mode to make sure you're in radians, or you won't get the right answer. Now I want to check 14.5 hours after midnight, so I'm going to go into my table set, second window, and I want to start at 14.5. So I'm going to go into my table and figure out what the corresponding y value is, and that is 30. So that's the temperature at 2:30 in the afternoon. It's 30 degrees Celsius. So my answer there would be 30. Okay, partial graph of a sine function shown below. A possible equation of the graph is what? Okay, so it looks like this is going to be tied to period. So I can see that by the time I get to k, I've done 2 cycles. So that means if I do 2 cycles by the time I get to k, I've done 1 cycle in half of a k, which means my period is k over 2. So what it comes down to is just figuring out what my b value is. So on our formula sheet, we have period is 2 pi divided by b, but I'm going to switch that around and say b is equal to 2 pi over the period. So my b value is 2 pi divided by my period, which is k over 2. So I'm going to just write this out this way. I'm going to say b equals 2 pi divided by k over 2. So instead of having a fraction over a fraction, I split it up like that. And then I know to multiply, to divide fractions, I multiply by the reciprocal, which is 2 over k. So 2 times 2 pi is 4 pi, and that will be divided by k. So that makes this the answer, because there's the correct b value. Okay, partial graphs for sine and a sine bx plus d, where a, b, and d are whole numbers, are shown below. Write the value of a in the first box, value of b in the second box, value of d in the last box. Okay, so basically we just want to find out a, b, and d. So let's identify max of 7. And here I have a min of 1. So my d value is the average, 7 plus 1 divided by 2. So that's 8 over 2 is 4. So that'll go in the third box. Then let's figure out your a value. A value is half the distance. So 7 minus 1 over 2. So that's 6 over 2, which is 3. So 3 goes in the first box. Now I just have to find out what my b value is. And to do that, I need to know my period. So if I look at my, I'm going to draw in my midline at 2. Is that where it is? No, my midline is at 4. So let's draw in our midline at 4. There we are. Okay, so I know that sine is one hill, one valley, and I start right at 0. So that's going to make it easier for me. So I'm going to do one hill, one valley. So here's a hill, and here's a valley. So the distance between this point here and this point here along the horizontal axis will be my period. So if I slide those down, it's going to be between 0 and pi. So I know that my period is pi. And to figure out my b value, remember on your formula sheet you're given period equals 2 pi over b. I can just interchange the b and p and get b is 2 pi over the period. So my b value will be 2 pi over my period, which I said was pi, and then I cancel those and I get a b value of 2. So that means that the answer is 324. Okay, let's look at the written response question. So it says, use the following information to answer the questions on this page. So we have the average monthly rainfall in a town shown in the chart below, collected over a 30-year period. A student plotted the data using a scatter plot feature of the graphing calculator and obtained the diagram shown. It appears the data could be modeled by a sine function with a period of 12 months using a domain of 0 to less than 12. In other words, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. The following questions relate to the different methods which the equation of an appropriate sinusoidal function can be determined. Okay, so we can put anything in this formula here when a is greater than 0, and I want to explain how the values of a and d can be determined from the max and min values of the function. So remember, your a value is the average distance, max minus min divided by 2. Your d value is max plus min divided by 2. That's how we can figure that out. So in the chart, we can actually use all of these numbers to come up with the equation. So the period is 12 months, and we want to find the values of A, B, and D. Our C value is given to us. So let's identify the max and min values in the chart. So from the table here, I can see that the maximum value is 167, and the minimum value is 36 right here. Okay. So if I want to figure out what my a value is, it's going to be 167 take away 36 divided by 2. So I'll have an a value of 65.5. My d value, I'm going to do 167 plus 36 divided by 2, and I will get a d value of 101.5. So I've got my a and I have my d. I just need to figure out my b value. I'm told that the period is equal to 12 months. So remember that period is 2 pi divided by b, or b is equal to 2 pi divided by your period, which is 12 months. So using this formula here, I know that the b value is 2 over 12 in lowest terms, pi over 6. So putting this all together, I can have that r of t equals a, and then b t plus pi over 2. Oh, let's try this again. Pi over 2 bracket plus your d value of 101.5. So that's one way of coming up with the formula. According to the model in the previous bullet, what is the average monthly rainfall in the town to the nearest point 1? Your average is always your d value. So the average is 101.5 millimeters. That's the average monthly rainfall in the town. And then we want to know in the month of February. So according to the model, what is the average monthly rainfall in the town to the nearest in the month of February? Okay, so this is the average altogether. So actually that doesn't answer my question. So in the month of February, come back up here, February, oh, this all got shifted over when I was moving it around. Okay, let's lock that in. So February is the third month. So when t is equal to 3, I want to know what the average rainfall equals, what y is. So all I have to do is put t equal to 3 in here, and then I can actually figure out what that value is. Okay, so let's use our calculator to do that. So we're going to enter in on our main screen because we're just trying to figure out the number. So we're going to go 65.5, and then we'll go sine. And it's going to be pi over 6t. Let's put in our fraction here. So pi over 6, and then multiplied by t. And in this case, February is your t value, which is 3. And then we'll go plus pi over 2. So pi over 2. Close our big brackets. And then plus 101.5. So just plugging in your x value into your equation is going to give you the average value in February. And there we go, we do get 101.5. So it is the actual average value. Okay, so R is equal to 101.5 millimeters. Okay, let's look at another way of looking at this question. So in this one here, what we're going to do is we're going to do a sign regression. So the model is given by this sign regression. R is the average average rainfall in any month, where t is equal to 0 in November and t equals 11 in October, which is what we've set out right here. Perform the trigonomic regression on the data and determine the equation in this form where parameters a, b, c, and d are each rounded to 2 decimal places. Okay, so let's go into our calculator and let's clear out anything in y equals, turn on your plots. Then we're going to go into our stat and then edit. And we're going to enter in all the information in list 1 and in list 2. So I've already done that. So now we're going to do our sign regression. So let's go back out here and we're going to go stat, calculate. And remember, sign regression is at the very bottom of the list. There it is. Press enter. And then we're just going to go down here and store our regression. So just leave everything alone. And we'll go alpha, trace. Oh, let me try that again. I made a boo-boo. Okay, so let's try that again. We'll go through it again. So stat, calculate, sign regression. Let's try this again. So I want to store in alpha, trace, y1. There we go. I don't know what I pushed last time. Okay, and then we'll hit calculate. And it just takes a while to come up, and there it is. So let me just copy this over so we can do the equation. Okay, so over here, and I'm just going to copy paste this over, and we can kind of come up with the equation. Okay, so I want to round everything to 2 decimal places. So I have y equals a, 64.52, and then sine of b, 0.52t, plus c, 1.61, close your bracket, plus your d value, 100.97. So how does that compare to our other equation? If we look at, let's just actually copy this over here just so we can see how it compares to the other equation that we got down here. And just to see them side by side, you can see that my a values are pretty close and my d values are also pretty close. So they're both good ways of figuring out the equation. I would say that the regression is a little bit more accurate because it calculates all the average in between each of the points. But according to this equation, what will the average monthly rainfall be in the month of February? So back into my calculator. I've copied it into Y1 here. So I want to know for February. So let's go into our table, and we're going to start our table at the 3rd month for February, and then go into table, and you can see right there, it's 98.9. So in the last one we got 101.5. This one here we're going to get to the nearest whole number, to the nearest millimeter, would be 99 millimeters. So 2 ways of doing the same question. Okay, I prefer the sign regression because I just put everything into my calculator, and then it's just easy amount of keystrokes. So I hope this helped. Lesson 8 practice test, and I'll see you for the next one.